They move through the darkness like ghosts. Silent, precise, unseen. From the grasslands of Africa to the dense forests of South America, big cats like lions, leopards, jaguars, and tigers rely on one of nature's most extraordinary gifts, night vision. Their ability to see in near total darkness gives them the edge as hunters. It's what allows a lion to stalk prey under the cover of moonlight. It's what helps a leopard navigate dense jungle foliage long after the sun goes down. But what if we took these predators far from Earth? Far beyond any forest or savanna? What if we placed them in a setting that is darker than the darkest night, a place where sunlight doesn't reach at all? Would their night vision still work in deep space? To answer that question, we must first understand how big cats see in the dark. At the heart of their night vision is a structure known as the tapetum lucidum. It's a reflective layer behind the retina that acts like a biological mirror, bouncing light back through the photoreceptors. This gives their eyes a second chance to detect any available light. That's why their eyes seem to glow at night. It's the tapetum reflecting light outward. In addition, big cats have an exceptionally high number of rod cells in their retinas. Rod cells are sensitive to low light and motion but cannot detect color. This means big cats don't see the world in full color like we do, but in low light, they see far better. In fact, a lion or tiger can see 6 to 8 times better in darkness than a human. That's an impressive edge in an earthly environment. But what happens when we step off this planet and into the void of space? Deep space is not just dark, it is absolute blackness. Unlike nighttime on Earth, there is no moonlight. No stars shining through an atmosphere. In many regions of space, especially outside the influence of stars or planets, there is no ambient light at all. In such conditions, even the most sensitive biological eyes become useless. Because the tapetum lucidum only works when some light is present. It can amplify light, but it cannot invent it. So if a big cat were exposed to total darkness, like a spacecraft interior during a power failure, or a region of deep space with no illumination, its night vision would be no more effective than ours. The biology simply has nothing to work with. But the scenario changes if there is even a trace of light. Say, the faint glow of a control panel. Or scattered starlight filtering through a ship's viewport. In that case, the big cat's night vision would kick in. Its rod cells would absorb what little light was available. Its tapetum lucidum would double that input. In a low light but not zero light environment, like the shadowy interior of a lunar base or a Martian cave, the big cat could regain its edge. It would be able to detect motion and shapes long before a human ever could. So in a space habitat, with artificial lighting kept at low levels to preserve energy, or to simulate a natural day-night cycle, big cats would actually perform very well. Their vision would be a huge advantage in patrolling corridors, hunting pests, or even navigating during blackouts. But let's consider another possibility: alien worlds. On exoplanets orbiting distant stars, where light levels may be permanently low due to thick atmospheres or distant suns, night-adapted predators would have the upper hand. If humans were to terraform such worlds or build colonies in shadowy environments, Like the ice caves of Europa, or the subterranean tunnels of Mars, we might someday consider introducing or genetically adapting creatures like big cats. Imagine a panther genetically enhanced to function in a space colony, outfitted with a suit or skin modified to adapt to low oxygen and cosmic radiation, silently navigating the dark tunnels of an underground base. Its natural eyesight, already optimized for darkness, would be paired with sensors or bioengineered enhancements, allowing it to operate where no robot could tread undetected. But here's where things get even more interesting. Could human technology enhance big cat vision even further? Scientists are already exploring biomimetic sensors inspired by animal vision, devices that mimic the way creatures like owls, cats, or insects process light. In the future, we could design artificial tapetum-like layers for humans, or implant optical enhancers into animal companions. We might equip space-adapted animals with low-light augmented goggles, powered by starlight or thermal contrast, enabling them to function as biological scouts in alien terrain. It's not as far-fetched as it sounds. The US military has already studied cat vision to improve night vision goggles. Their ability to detect contrast and motion in darkness is being used to design more efficient sensors and visual processors. Which brings us back to the original question. Would a big cat's night vision work in deep space? In total, lightless vacuum? No, because no natural eye can see in complete darkness. But in any environment with even trace levels of light, whether artificial or natural, their vision would outperform almost every other terrestrial species. They would be formidable in dimly lit space stations, lunar caves, Martian tunnels, or dim exoplanets. More than that, their biology could help us understand how to see in space. How to design better sensors, better navigation systems, even better tools for deep space exploration. Because when we study creatures like big cats, we aren't just looking at the past. We're catching glimpses of a future where biology and technology move side by side into the cosmos. Where the silent predator of the jungle becomes the silent guardian of the stars. And in that darkness, far from Earth, the eyes of a big cat may one day lead the way.